Okay, I'm gonna go ahead and jump into some stuff with Rhino. Hi, Mark. We're just getting started. I'm using Rhino 8, and I committed the sort of very common error of trying to use Rhino without connecting to Global Protect first. Wah, wah. But it's just one of those things. So this is a file that I'm kind of working on in my own research, and I thought it would be a really good way to kind of talk about how to get started with a 3D print. So this is kind of not really important what this is, because what I'm going to do is I'm trying to make these forms so that I can snap them together. And so what we're going to work on today is just a couple of scale tests of this snapping part. And so literally we're going to make a box with a hole in it, and we're going to make a piece that can slide into that hole. Okay, so it should be really like simple, kind of, fairly basic. I definitely can do more demos on how to use Rhino in 3D. Although I think most of you probably know about my YouTube channel, which might also be a really good way to get some practice with Rhino. I know I have a playlist of like 7 videos with Rhino 7. So anyway, so I just opened up a new document, and I am making the first thing that I want to do is go to my settings. In this case, I'm going to work in millimeters. And I want to keep in mind that the object that I'm kind of wanting to work with is about 12 millimeters wide. So I'll probably go back to that measurement at some point, but all that to say that I don't need like hundreds of millimeters of space on the grid. I just need a pretty small grid. So I think making the minor grid line spacing every millimeter should be okay. And then we could have major lines at every 10 minor grid lines. That seems completely fine to me. And I'm also going to check my units. And I'm just going to make sure that both of my units are in millimeters, and they are. In general, the 3D printing software really likes millimeters. It will print objects in inches, but it's possible you may have to do a conversion. If you designed your object in millimeters and you want it to be in inches, you usually have to multiply it by 25.4 or divide, depending on which direction you're going. So that's the magical conversion number. My advice for 3D printing is just to work in millimeters because it's easier. So this is really all that we need to do to the grid at this point. As I'm doing this, I may change the grid a little bit to accommodate a finer spacing. And it looks like my snap spacing is at 1 millimeter. And to be honest, for this project, I think it might make more sense for me to make it like, I think it's fine. We'll change it later if we need to. Okay. And I'm just going to go ahead and save this with a name. So I called it 3D snap test. And so I'm going to start by making 2 forms. One form that I am going to make, I'll go ahead and I'm just one of those people that likes to work in the top view a little bit more. So I'm going to go to this box form, and I'm just going to make a box that is roughly maybe 20 by 30 millimeters. So in order to do that right now, you might notice that my grid snap is not turned on. So I'm going to turn on the grid snap. That was the whole point of spacing out the grid. And I'm just going to make that box about 20 by 30 here. And then probably about maybe 15 millimeters up. So I just sort of did that by, I eyeballed it, but you could certainly type in 15 if you want to really make the point. So I've got this box, and I'm going to show you another way to make a box, because we're going to need a couple of little boxes, because I'm going to do these holes and rods at different sizes. So another way to make a box in Rhino is to actually start from the curve. So what we did here is we basically just made a shaped primitive by using the box command. So this is like go directly to a solid box. If you start with a curve, there's a more complicated process, and some things can potentially go wrong there. The nice thing about using these shape primitives is that they are guaranteed to be watertight. So what does water tightness mean? Well, I will have to show you a model that is not watertight in order to kind of drive that home. So when we make the second box, we're going to make it in a way that is basically wrong, or in a way that won't print. And then I'll fix it and I'll show you the difference. Okay. So to start our box, I'm just going to do the same thing I did before, which is make a 20 by 30 rectangle in this case, using the rectangle command. And I think here I would go ahead and go to the surface menu and extrude curve straight. And then I can extrude it to the top level here. Now, I'm going to turn on my rendering in my perspective view so we can get an idea of what's happening. My personal favorite view when I'm using Rhino is to use the ghosted view, because you can kind of see what's inside things in case things have gone terribly wrong. You could just as easily use the shaded view, but for me, seeing a little bit of that interior is really helpful. So basically what you can see is that we took that curve and we extruded it into a surface, right? So it would be fairly easy to fill the bottom by making a surface that conforms to this curve. And that's over here in the surface model, the surface list called planar curves. So this is indeed a planar curve, and it can just have a surface constructed around it. Now, I want to show you, first of all, which of these models is 3D printable and which is not. Yeah, the one that is fully filled in on all 6 sides is 3D printable. This, if you fed this to a 3D printer, it would literally print nothing, because the surfaces have no mass, and they are not what is called a watertight shell. So now you may be asking, well, what if I wanted to print an open box like that? I would say, okay, we'll talk about that in a second, maybe after I do my rod things. But for now, I also want to show you another sort of way of making this not sort of right. And that would be, let's make a rectangle that goes from here to, let's say, here. And I'm just going to raise it up to the level of the other ones. And, oh, I moved the wrong rectangle. Sorry. Move the right. Okay, so now I'm going to fill in that surface by using the planar curves method. Is this object 3D printable now? It is not. It's not. So this is basically an object that is like most of the way there, but it's not watertight. Now, I think in this case, it's really obvious like that it's not watertight, right? Because I made that gap pretty large. Where you run into trouble with Rhino is that this lack of water tightness can sometimes be beyond the seeing eye. Like it's so close that only the exporter can tell you that it's not watertight. And so if you're having problems with water tightness, I will say a few things. Use your snaps. That is the best way to ensure in Rhino that things are watertight. If you're expecting to move something to another node or another line and you're not using a snap, I can almost guarantee you that that form will not be watertight. So definitely using the snaps and making sure that everything snaps together is like the #1 way that you can make things watertight. So this is easy enough to fix, actually. I can just take this surface and turn on the edit nodes here. Where is that? It's right here, control points. And I can basically just take one of these points and move it over here and take another one of these points. I could even move them both at the same time if I wanted to be really fancy. And there, now our model's fixed. So that's pretty much what it takes there. So I'm going to go ahead and still keep using these two boxes. They're basically identical, but at this point, I'm hoping to have some forms that create holes inside of them. And so I think what I'm going to do there is I'm going to go ahead and make a cylinder. And I'm going to make it, let's see. I think I'm going to make it 6 millimeters to start. And I can certainly now extrude it to give it some height. So I can go up here to solid, extrude planar curve straight, and just give it some height. I want it to be a little taller than the box. And then I can just move it into the box. And I think I'm also going to take this 6 millimeter object. And so the issue with this kind of a thing in 3D printing is if I print the rod, let's say, and it's 6 millimeters, and I put it into a hole that's exactly 6 millimeters, it's not going to work. It'll just be like, bonk. It won't go through. So there's a tolerance because the 3D printer is not like, accurate to the thousandth of an inch or whatever. So we have to basically make our hole a tiny bit bigger. So what I'm going to do for that is I'm going to go ahead and take this 6 millimeter rod. I'm going to move it so that it's in a couple of different places. And I think here, what I'm going to do is I'm going to make a cutting object here that's a little bit larger. So I'm going to make another cylinder that's basically in the same place as the old cylinder. And I'm just going to make it a couple different sizes. So this one is 6.7 millimeters. I'm hoping that that will be the largest amount of tolerance, but I think I could definitely make one of these that's also like a half step between. So I'll go ahead and make yet another circle. This is where I thought maybe my snaps needed to be a little bit more nuanced, but I think I can get away with doing a midpoint here. Whoops. Excuse me. That didn't work out so well. So if you're having trouble using your snaps, like right now, it's not 100% snapping to the midpoint because it's like too focused on this endpoint. So I could turn the endpoint snap off, and then that kind of forces the issue. Oh, come on. Okay, I'm gonna force the issue here. This is sometimes when stuff isn't snapping, like I'll just throw down a little line segment to basically like force the issue. So I'm just drew like a tiny line segment there. And that's gonna allow me to use that midpoint. There we go. Sometimes the snaps can be a little frustrating in Rhino. I did just say that out loud. So now I'm going to take these two forms and I'm going to extrude them into solid forms. So in order to do that, I'll use the solid menu and do like extrude planar curve straight. And I'm just going to use the same height that I've been using for the others. And so this now can just kind of get moved over here and we can place it later. Actually, I got a tiny bit turned around just now. Hang on. Okay, so, all right. So let's see. So this is our first form. I actually want the extrusion, not the curve. And I'm going to hold the shift key down because I would really like to kind of move this in a full ortho mode here. As you can see, it's kind of snapping back and forth. So we can fix that later, but I want to go ahead and get these moved into place. This one needs to be extruded, so we can extrude this one down. Yay. And so now I can move this extrusion over here. I'm just kind of putting them in place so that I have some idea of where they can go. And then I'm going to use the actual move command to precisely move them over the other ellipses. So here, I'm going to take this one and use the actual move command. And I'm going to activate the center option. So I'm going to try to basically move it from center to center. And I think that's exactly where it should go. So I'm going to do the same thing with the other one. And again, I have my center snap activated. So I can just go to the move command and pick up the center of the large one. And then move it over the center of the little one. Yay. Okay, so now what does that look like? Well, let's see. Right now, it looks like I have to adjust them a little bit in the Z dimension. So basically, this would be a good opportunity for me to use the layers palette because these sort of rods right now are purely decorative. They're just there to kind of be there. I don't know exactly why. I think they were there mostly just for placement. So I don't really need them right now, and they're not kind of helping because the holes are going to be these larger curves. Also, I think just for the sake of time, I'm probably going to stick to these two, and we can kind of see how that turns out. And then I can, do the rest on my own. So I'm going to go ahead and go to hang on just 1 second. I have to move my Zoom thing. So I'm going to bring up the layers, and I'm a huge fan of using layers in Rhino. I think it's a great way to sort of get rid of stuff. but keep it where you need it. So I'm going to select these two things and go to a new layer and right click or control click, and I can do change object layer, which is basically just going to put these guys on the red layer, and then I can get rid of them. Now, I do need to take these two sort of whole objects and pop them up to the level of the other ones. Hopefully, I can do that without moving them in the XY dimension. Whoa. Okay. Another thing that I'm going to do, just because they're kind of interfering with my snaps, I'm just going to get rid of these two for sake of simplicity. And then that'll make these easier to like move into the proper place. Now, if I hit shift, it will keep it in ortho mode, which is ideal because I don't want these to shift in the XY dimension because I just took great care to place them, in a certain spot. Okay, so now I want you to just notice that I'm moving these forms so that they overlap both sides of the box. You could have them flush to one side of the box and still make a hole, but it works better if it fully contacts the box. Okay, so I'm basically good now. Now, what I want to go ahead and do here is I want to take these forms and I want to subtract them from the box. So in Rhino, there's a set of operations called Boolean operations. And basically, you can take one shape and you can subtract another shape from that shape. So I think what I'm going to do here is go to the solid menu and Boolean two objects. I personally like the Boolean two objects function because it lets you browse through all the ways of subtracting or intersecting rather than having to just pick one. There are some reasons why you would choose these other methods, but they're sort of encompassed in the Boolean two objects method. So here it says select two objects to Boolean. So that would be the box and let's say hole one. And you just click until you get the result you want. It'll show you a couple of different ways of, subtracting or adding these objects together. And then you hit enter. And so now you can see we have a fully holed out hole. And then we can certainly do it again for the other hole. So in Rhino, a good Rhino hack, if you hit enter, it will bring up the last command that you used. So if you're doing something repetitively over and over again, hitting enter is like a super easy thing. So, okay, so I'm going to go ahead and select these two objects and then click through my options. Yay, thank you. If I were doing this on my own, I might consider making this have a little bit more real estate here. This is going to be a little thin, but it'll be fine. It'll definitely print just fine. And I'm going to just go ahead and bring my rods back into the mix. So basically, right now, we could 3D print this. And it would 3D print as one model, but three separate objects. And I think that's what we're going to do. Can I guarantee that these rods are going to slide around in these holes? No, I can't. I mean, it's a test. But that's the kind of testing that you have to do if you want stuff to fit together. So I did want to show you one other sort of thing in Rhino that might be kind of useful, and that is the shell command. So if, let's say, you wanted to print a box that was hollow, I'm just going to bring back our old box from before. You can certainly do that. So there is a command in Rhino called the shell command, and I'm actually not sure where it is. I always just type it into the command thing. And it's called shell. So if you type the word shell, it'll come up. And then it says, okay, select a face to remove. Now, this thickness parameter is the wall thickness that you're going to get. So we might actually want to go for something like a little bit thinner, like maybe 0.5. That would be really slick. And Elena, what's the thinnest wall thickness you would do?
I would say probably like the thinnest ball thickness you could, like reasonably do. At a certain point, the printer is just like not going to be able to print it. I would say like 22 millimeters, like whatever your layer height is what I would make like your thinnest wall.
Right, because the printer has like a nozzle that's a certain size, and so you definitely can't go like less than that, right?
So depending, like it really depends what you're printing. If it's anything structural, if it's thinner than like your layer height, it'll typically when you're printing like it's solid here, but when it gets sliced, it creates perimeter walls. And so if it's thinner than your extruded layer height, it's like gonna do less than one perimeter wall. Like it'll just do a very thin layer, and that will just like break right away. So I'd say like 0.2 millimeters is like the smallest, like the thinnest wall thickness I would go.
Yeah, awesome. So basically this has been shelled out now, and this form is completely 3D printable because it has a solid sort of surface that goes all around it. So that surface to surface sort of thickness, you know, can be quite thin, but yeah, there is a practical limit. Awesome. So basically, I think now I'm going to show you how to export this and get it into Prusa Slicer. So before I abandon this model, I'm going to do a tiny bit of housekeeping. I'm going to go ahead and take these curves that I had made before, and I'm going to select them. And this is just something that I do like repetitively in my own work. I make a layer called curves. And I just throw stuff on it by doing that change object layer. And then I even make it invisible. And mostly I just store those curves in my Rhino file, because if I go to like make the surface a different size or whatever, they're there and I can use them again. You know, I don't like doing things twice. So now we've got some objects on the screen. Let's say I wanted to have these three objects be my 3D print. It's pretty typical when I work in Rhino for 3D printing. I usually have a ton of stuff on the Rhino file, but I just want to 3D print like this one thing. So there is an export selected function in Rhino, which is super helpful. And you can go straight to that. So I'm going to go ahead and save this in my class folder. And I'm going to export it as an STL. Now, there's an options palette here. Honestly, I don't think any of this matters, but you probably want to have this box checked that says export open objects. The only reason I say that is that, you know, you might think, oh, that's bad to export open objects because they're not 3D printable. Well, they might be. The 3D printing software has gotten a little bit more forgiving over the years. And so sometimes you can get it to work. So I just enable that. So if there's some teeny tiny problem, sometimes the 3D printing software will just gloss over it. So then you can export. There's a setting here for tolerance. And certainly if you're working on an engineering project and you need a certain tolerance, I would, you know, be mindful of that. For general purpose 3D printing, this is going to be way more than you probably need. This is like, well, 1/100th of a millimeter. If you worked at 1/1000th of a millimeter, it would just increase your file size. Like, I don't necessarily feel like the 3D printers are capable of representing that level of precision. So you're just wasting hard drive space. So you can go ahead and click apply and then finish the export. Okay, so first, one thing I'm going to do, I'm just going to preview my STL file. So I think I might have told you all about this program called MeshLab. If you just Google it, you can download it. It's a free polygon mesh viewer. And it's really great for kind of checking out 3D models before you print them. You can actually do some things to it if you're using the 3D scanner. It's really great for 3D scanner data. And so it's definitely like something to think about. So I'm actually going to have to import the mesh. And where did it go? There it is. Just go for the defaults there. And so as promised, we can kind of see our little test here. And so MeshLab is really, the reason I like to use MeshLab is because, is that Aaron McAdams? Oh, hi. Hi. The reason that I like to use MeshLab is because, like, let's say you've got like a bunch of 3D printing models. Rhino takes forever to start up, but MeshLab is like, hello, I'm here. I'm going to show you your model. And it's just like light and easy. So anyway, I just am basically verifying that it exported correctly and that all of its holes are in the right place, blah, blah, blah. So now I can exit out of this. And now I'm going to open up Prusa Slicer, which Prusa Slicer is basically what we are going to use in this class to get us from a 3D model to instructions for the 3D printer. And so when you start Prusa Slicer, go ahead and maximize it here. Maybe not that much. Sorry, hang on. Okay, so basically when you open up Prusa Slicer, you get this. And I think from here, you can add a model. So I'm going to go ahead and just find my little model here. It actually brought it in the correct orientation, which is kind of surprising. It usually doesn't. But the best way to kind of change the orientation are through these rotate tools. And you could just grab the wheel and kind of rotate it to wherever you want. If you can click it to 90 degrees, that's nice. But we don't really need to do any of that. There's a bunch of other stuff going on with Prusa Slicer that I think we'll get into over the next like week or so. But for now, I think we're just gonna like make a print and keep it pretty basic. So the first thing you might want to think about is just verifying the dimensions of your object. So if we click on the object and we look at it over here, hey, guess what? It's 30 by 20 millimeters and it's 18 millimeters on the Z, which sounds absolutely perfect. So definitely checking the dimensions like right away is a good thing because if you get sort of down the rabbit hole and you haven't checked your dimensions, that it will cause you further problems. So we also have a variety of settings. Now, I'm just going to move this down here for now. We're in the plater view right now, and the plater view is basically where you can see your 3D print to be in a human viewable form. So it's like a 3D shape, right? If we go to the other view, which is the sliced view, you'll get cross sections of it when we generate the G code. So over here on print settings, I mean, we could talk at length about print settings. And as you can see, there's quite a bit going on here. There's like all kinds of, tabs in here. And to be honest, it's quite complicated. What I think that we can do to get everybody started is to give them a config file that represents settings that we would recommend, right? And so I've gone ahead and, am using that config file, and I'm going for like a 2 mm quality here. On the filament, I'm using the generic PLA setting. And then on the printer settings, I am using this original Prusa with the 0.4 nozzle. The big orange box is sort of my my printer in my studio. So I have my own profile for each printer. Okay, so getting into the print settings, there are certain print settings that matter and certain print settings that, you could like ask how many angels could dance on the head of a pin. There are the print settings that really, really matter are layer height, infill, and speed, I would say. And then there's other important stuff, but we'll get into that as we need to. So layer height, I basically, if we go back to print settings, I have the layer height set at 0.2. 0.2 is what most people would consider like a draft quality. And to be honest, I think we've covered this before. I'm highly impatient. So I tend to print at a higher layer height because I just don't care about the surface finish being like perfect. I'd rather get my print like right away. But certainly if you're looking for surface finish, you could go as low as like 0.5 or maybe lower.
So
Yeah.
I think that the most important one is like, if you want to do bigger layers, you can't have it be more than like 80% of your nozzle extruder, because it just won't be able to push out enough. For layer height, you can go almost as small as you want, or if you're doing like a really quick draft, like you need something fast, you can't be bigger than like 80% of your nozzle height. So
Yeah.
fine.
Awesome. Well, and the other thing to think about is that layer height is directly proportional to the speed at which your print will be done. Because if it's making 2.2 millimeter layers, it's going to get, if it makes 0.1 millimeter layers, that means it's moving twice as much to get the same effect. So I think you can see examples. We have tons of examples of all of these different settings and kind of how they play out. I don't really want to spend like a ton of time like talking about every little setting, but I think as your model kind of emerges, me or Elena can maybe talk to you about settings that might be very important for your specific model. Because a lot of the stuff just depends on like the shape of the model and how it needs to be printed. So there's a setting here for perimeters. That's actually kind of important. We usually keep it at 2. You could do more. And yeah, pretty much all of this stuff is just like standard to the settings that we have. Filament settings. Printer settings. I think I'm just going to go ahead and go with this. So these, the settings that I'm using are settings that Elena gave me that you mostly developed for the Prusas here. And so hopefully they'll at least give you a good place to start. Because if you take one of these printers out of the box and try to print with it immediately, out of Prusa Slicer, there's quite a bit of configuration that needs to be done. And so, yeah, thank you to Elena for nailing almost all of that. So, okay, so now, assuming that you've like played around with the settings to your great sort of joy, there's one other really important setting that you have to set pretty much for every model. I like to do a default infill of 20% at least. I'm actually going to do a tiny bit more for this. I'll do 25%, and that's basically how many sort of like units it puts inside to help the model maintain its structure. So in this case, because I'm expecting that I might encounter a little bit of resistance, it might be nice to have like a more significant infill.
Infill percentage is how much, like Meg is saying, how much material is actually inside of the perimeter wall. So a 25% infill means it's going to be 25% material and 75% air. So that's something to keep in mind. And then another thing to like that impacts your speed and strength in correlation to your perimeter walls is your infill pattern. There are lots of different infill patterns, which is not something you do in the designing it. That's something you select in the slicer right before.
Right. Yeah, totes. And I mean, you can get super nerdy about infill, and especially if you're working with like clear filament, it can be really pretty. The sort of different designs like hexagons or squiggles or all kinds of exotic stuff. Okay, we're ready to go. I want to print. So let's go ahead and slice now. And so slicing basically generates the layers of machine commands, okay? So now that we've sliced, I'm going to zoom in here and I'll show you what's going on with the slice. So one of the cool things about the slicer with a Prusa slicer is that you can really navigate. If you go to this preview view, you can navigate through the different layers of yeah, you can basically like navigate through the entire thing. And that can be super fun. Also, it gives you like a really clear way of seeing where your actual different types of paths are. And I'm sure you can imagine you can get super nerdy with that. Okay, so we're not going to do that today. So maybe let's export the G code, and definitely I would consider putting this on a flash drive. Prusa Slicer gives you a pretty elaborate name for your G code, and honestly, I think it's kind of helpful because if you change the printer settings, it has a really big effect on your file. And so you can just look at the file and say, oh, this is the 0.2 layer, or this is the 0.4 or whatever. So I'm going to go ahead and save these to my directory here. And I'm going to grab a flash drive.
Thing with your file that is not conducive to printing, Prusa Slicer will say, we'll give you a little warning. Don't ignore the warning. Like if it says like low adhesion or consider like if you have things to consider, it's worth until you get comfortable with the printer and the technology, it's worth just doing what it says.
Definitely.
Most of the time it's not a huge deal, and you can always like reprint it, but sometimes it'll give you like if you're printing off multiple parts and some of them are kind of like staggered in height and placement, like that can cause the extruder to crash into your print and make a huge mess and actually like harm the printer. So just like always pay attention, like when you slice it, if there's anything wrong that could lead to any of those things, it'll give you a warning. Just pay attention to those. And if you ever get a warning that you don't know what it means, ask one of us.
Yeah, definitely. I mean, I think both of us have like a ton of experience troubleshooting 3D printers. So it's kind of part of being a 3D printer user. Okay, so basically, I think I'm going to turn the recording off and we can move over to actually print this thing. I will see you all in a minute. I'm gonna decamp here.